I guess the main thing that kept me working and progressing is just the fact that I really love my job. I moved from industry to academia, and I stayed here because I know that I can do research on the area that I really love. It is really fascinating to see how they can progress, how they learn, and then I can even learn from them as well. It's not just me teaching, it's just me learning through my projects, through teaching here at the university. This is a great idea for people who are passionate to just see how things are changing continuously, and you have to be updated.
Welcome to Gridlock, Engineering for the Real World, the podcast where we explore the technologies, challenges, and people shaping the future of electrical power systems. I'm your host, Dr. Paul Moses, and in each episode we go beyond the headlines to talk with engineers, researchers, and industry leaders about the real-world decisions that will define the grid for decades to come. Today's guest is all the way from Australia, Sydney. Dr. Sara Deilami from Macquarie University in Sydney, Australia. Dr. Deilami's research focuses on grid integration, including electric vehicle charging infrastructure, distributed energy resources, smart grids, and the technologies that are transforming how electricity is generated, delivered, and consumed. She is leading the Energy and Decarbonization Research Group and is also the chair of the IEEE Power and Energy Society in New South Wales. Australia is often seen as a preview of the future of the electric grid, with world-leading levels of rooftop solar, rapidly growing electric vehicle adoption, and ambitious renewable energy targets. That makes it an ideal place to learn what is working, what challenges remain, and what other countries, including the United States, can learn from its experience. We'll discuss the future of distribution networks, integrating renewable energy in electric vehicles, energy affordability, rural electrification, and how energy policy and innovation must work together to build a more resilient and sustainable power system. Dr. Deilami, welcome to Gridlock. Sara, how are you today?
Thank you very much, Paul. I'm really well and very happy to be here. Thanks for having me.
Are you teaching right now? Is it holidays still there? Or
No, in fact, it's a very busy time. I have teaching this semester, and I think we are in week 2 of semester 2.
Okay, very good. Yeah, we still have about 3 weeks more, and then we start our fall semester here. So that's very good. So Sara, I'd like to get started to introduce you to the audience. Maybe you can tell us about how you came to be an engineer and what guided you into power systems particularly.
Yeah, sure. I guess my journey through electrical engineering started a bit different. I come from a family where everybody wanted me to be a doctor, to be honest, because they saw it as a profession that helps people. But from a younger age, I would say, I was always fascinated by solving problems, trying to taking things apart and playing with electronics, the little toys with wires and how things work. So I guess engineering felt like a much more natural fit for me. So after I graduated, I started working in industry as an electrical engineer for quite a while, around 10 years or so. And then a bit experience really gave me a real appreciation of how important the electricity system is and how in practice electrical infrastructure works. Then when I moved to Australia, I started my academic journey as an educator and a researcher, which is, I would say, my dream job, I guess, because it just helps me work with students and educate the next generation of engineers mostly.
Okay, wow, that's quite a fascinating journey in industry and academia. So comparing the two career paths, did you feel that your industry experience helped you in your academic vocation in teaching and research?
Definitely. The fact that I had this industry experience before, so I understand what the challenges industry might have, specifically with this transition of energy that we have. So I normally I work on quite different projects in different areas, and mostly they are industry based. Perhaps this is because I had this experience before in industry and understand, what the challenges might be. So how research can actually complement and help industry when we work together, definitely this would be really easy and useful even for this transition that we have in terms of the renewable energy integration.
Well, looking back over your extensive career, what changes in the electricity sector have surprised you the most?
That's a good question, actually. If I look back, there are so many changes that happen, but the biggest surprise is how AI, artificial intelligence, has become part of the electrical industry and has changed everything, transformed everything, I would say. So if you look at electrical system, we use artificial intelligence in every day, I would say, from forecasting electricity demand or renewable energy generation, like wind, to optimize electricity or electric vehicle charging, discharging scenarios, or detecting faults perhaps for the networks in distribution system, for example, switching networks, or even inspecting solar farms using drones and satellite images. I guess we have AI, we have a lot of data centers right now. So not only it is, I would say they are bringing more opportunity for us. At the same time, there are challenges in terms of how they are adding more electricity demand. So we definitely have to just see how we can balance the generation demand in this case.
Interesting you mentioned AI and data centers. Like here, it's a very controversial topic. There's the utilities are very struggling to keep up with this demand, and in fact, they have to turn away potential AI clients because the infrastructure is not ready. And on the social side, there's a lot of opposition and people who don't want data centers nearby because of the impact on the cost of electricity. In Australia, do you have similar problems, or is there more acceptance there?
I guess in terms of the acceptance, I haven't heard anything against the data centers, of course, because we can see AI is increasing and it is very popular. Of course, everybody is just using, and we can't actually underestimate the fact that AI is really important in even not only power industry, in other sectors like health or software and economics. Data centers, are, I think, must, and they are supporting AI as well as, cloud computing. So the question is how government or industrial utilities are trying to cope with this. As we said, of course, the infrastructure is not ready. We have a lot of electricity demand or grid stress for the grid. And then the fact that it's just really the matter of how much cost they have to invest to make sure that we have data centers as well as other, I would say, stresses. I would say we have a lot of renewable energy resources, specifically in Australia, and like solar panel, of course, because of the geography of Australia, we have a lot of wind and solar here. So it's not just about data centers, but of course, I can't say people are against it, but the question is more about how we can supply or power this sustainably.
Okay, that's very fascinating. And Australia has a very unique layout because it's mostly a coastal populated area. And I think the west side, Western Australia, where we studied, and the east side are not connected, right, electrically? Or
No, actually, the national electricity market for the whole country, I can't say is just interconnected. Perhaps in US, we have an electricity market, which would be, I would say, the grid is connected together the whole way. But here we have a national electricity market for the east side, and the Western Australia is separated. It's just inner west system, which would be separate from the eastern Victoria, New South Wales, or Tasmania or so. But as you said, this is all about the geography of Australia. It's just quite really large.
right, okay. And you mentioning renewable energy, you've had, I've seen in your publications and your projects, you've had a lot of involvement with rural areas and helping those communities access energy. And how could you tell us a bit about those projects and with the rural communities?
I've had the opportunity to work with regional communities back, I think, in Perth a few years ago when I was working at Macquarie University. We had a project with Department of Communities, and the project was around, I think, Northern Territory, and we were trying to see how we help the system with its feasibility study and try to design a renewable based microgrid for 3 regional communities in one side of north side of Perth, and also another community again in Northern Territory. I guess that was a great opportunity to design that system. We're looking at solar power systems as well as energy storage. And of course, as a backup, they had diesel generators as well. But those communities were for indigenous people here. And I guess that was a great experience for me to just move into renewable-based microgrid projects.
And I've been reading that Australia is actually leading in this concept of virtual power plants and using home batteries. I think even in the US, they're starting to do that in California, but I think Australia has much more involvement with the utility, controlling batteries and vehicle-to-grid integration. Do you have much information about that and how that's going with the utility? Is that a success, or is there challenges with that?
When we look at Australia, we have a lot of wind farms and solar farms, again, because the location of Australia is such that we can actually have these solar farms. The other thing is we have 4.4 million almost households having rooftop PVs. And I guess it's just overall for the country is around 41% of the total population, which is really good. So that means we have a lot of renewable energy coming in, and the generation that we have is just coming from solar systems, perhaps. But the problem is not having renewable energy generation here. Of course, during the day we have sunshine here, and we have a lot of energy. But then the problem is how we can save this and use it later, for example, during peak hours or evening. So that's where the role of battery energy storages or, virtual power plants come to the picture. Still, we have the other problem that we have in here is not all of the people can afford these rooftop PVs, or perhaps they are renting houses or they are in apartments or say in strata buildings, and there are the rules and regulations are a bit complicated towards having rooftop PVs. And that's why I guess utility and government try to come up with new ideas of how to first cope with this excess energy which is coming to the network. Sometimes we have even negative wholesale electricity price, which is not, it's at a low level. And then the cost still for the electricity is quite high. So how can we actually manage this? So that's why we have now the energy storages. Most of the houses, they have home batteries, trying to see how they can actually perhaps reduce the cost involved with electricity bills. But the other thing is community batteries and virtual power plants, as you mentioned. So we have a smart management of the systems in place to, if we have virtual power plants with different schemes, dynamic tariff pricing, how people can join and register and be part of the schemes to help them with the cost involved, or even if they don't have rooftop or storages, if they are as part of these virtual power plants, they are able to still use that energy. So that would be a fair, I would say.
Okay, yeah. One of the problems in the US is that we have a very fragmented regulatory structure and many different types of utility business models. So in Australia, do you think that the electricity markets and the regulatory structures, billing models for the customers need to evolve to better reflect what you're talking about, to adopt all this? Or is that satisfied now, or there needs to be improvements?
I guess there is always room for improvement, Paul. I guess a few years ago, if we looked at what happens with rooftop PVs, we have solar energy here, and what we can do, we're always asking, okay, where these rules and regulations come in place and how they can help. But after in the recent years where I was working in this area as well, I could see a lot of improvements. We have Australian energy market operator who is actually overseeing everything for national electricity market here in Australia, trying to plan and see how the rules and regulation works in terms of even interconnection between the generation side and distribution or transmission side. There are different standards or rules related to this interconnection between the generation and how they are looking for this balance between generation and demand. Definitely, we are in the right direction. I think Australia is in the right direction, moving towards how policymakers, utilities, or even end users work together to understand how we can move towards this transition. Maybe before, we didn't really have these schemes, dynamic tariff schemes or virtual power plants. Now we have a lot of pilot projects for community batteries. I would say that would be perfect in terms of how we let people use the energy to just put everything in the community batteries. It's not just individual whole batteries. So there are so many rules and regulations that are now have improved, or they're getting in the right direction, I would say.
Okay, well, related to that question, how are utilities, governments, researchers, and even community stakeholders, the general public, working together? Are there enough forums for the community to voice their concerns and be a part of policy making? How would you describe that there?
Of how they collaborate with each other. I mean, all the parties need to actually collaborate to make sure that we have, from my view, I think there has to be a policy, then we come up with the design based on the policy that we have and make sure everything is right. And then we move towards, how we can upgrade the system. For example, if you look at aging infrastructure, in reality, this, I would say, maybe is not working right now, but I know utilities, researchers, and the government work together tirelessly, specifically through different funding scenarios that we have, specifically between researchers and government. Now that we know and understand the gaps where we have to improve, government is just really trying to help researchers as well as the utilities. So we have arena funding projects, for example, for vehicle to grid opportunities or virtual power plants or smart charging scenarios. A lot of researchers are trying to help develop new ideas or new technologies for this. And from the other side, we have regulatory, parties try to deploy this in a safely manner, I would say. So that is the combination of this collaboration together to make things happen. Otherwise, nothing will work. I remember a few years ago when I wanted to start working on my wireless, I work in a wireless power transfer system here in technology. A few years ago, I didn't think that a public acceptance is there, even from the government side. And I was actually struggling to join in a project to start developing the system. But now things are different. Government is quite supportive. We have projects with government and even with energy providers to make sure that everything is just moving towards a target. I mean, Australia has an ambitious target of 80% renewables, around 82% of renewables by 2030. So I think that's why we're just, pushing. Everybody is just trying to pushing this through.
Okay. And do you feel that there are any technologies or ideas that you believe deserve more attention than they're currently receiving?
I guess, we are now retiring coal-fired power stations and trying to have more renewables as alternatives here. I guess one thing that I was just thinking, if you're retiring coal-fired power plants, that means the conventional synchronous generators that we have had before now will be removed from the picture. So if you're dealing with the grid resiliency, if you're looking at maintaining 24/7 voltage and frequency, how can we actually do that? If you're moving towards renewables and advanced power electronics, I think inertia would be one of the problems that we have to see how we can deal with. And I guess virtual inertia, how we can use that for maintaining the frequency imbalance in the network would be something that we could actually look, or grid forming inverters right now, how a grid forming following can actually work together. That is something, I guess, it needs more attention. Or in terms of the alternatives, one other thing that I just remember is I know that in US we have nuclear power plants, and perhaps part of the electricity is coming from nuclear power plants. But here Australia is just a bit at early stages, we don't really have a nuclear power plant as an alternative. I don't know if this is good or not, but I guess that would be another resource that we can think of later on as we go through this process.
Right. I mean, here we do have nuclear, but it's undergoing like a renaissance in the sense that for a long time it's been very stagnant. There's no growth there. But there's the concept of small modular reactors is gaining some momentum, where instead of these huge, large nuclear plants, you have more modular, smaller ones that you can deploy near a data center, for example, and so on. Yeah, so it's quite a interesting time here as well with where we're going with the nuclear industry. That's interesting. What pilot projects are being done there in Sydney or in New South Wales that demonstrate some of these new technologies? Are there, like, for example, microgrids, and you mentioned virtual power plants. Are these still in the pilot stages, or are they now anyone can do this?
The moment around, I would say the pilot projects that we have, perhaps in Australia and even South Australia, is really leading this. It would be vehicle to grid technology. The option for the cars to have this, and then later on, as part of the system, we can rely on vehicle to grid, is something that is, I would say, at early stages. I think there are some sort of rules and regulation around this, but I know there are trials or happening in Sydney or even South Australia, for example, in Tasmania. But there are virtual power plants. No, I think now we're working in virtual power plants at the moment. I think there are some schemes where even households, residential areas are able to join the virtual power plant. So they are at the stage of implementation and they're working in this area, but not for vehicle to grid technology.
Right.
And even wireless, I don't hear any project currently going on for wireless power transfer. What we are working on this technology right now as a complement. I know we have a lot of, say, fast chargers as infrastructure to deal with, the range anxiety and EV adoption here, but I guess that would be as a trial stage right now, and we're going to, start demonstrating in New South Wales.
Okay, let's zoom in on that, what you mentioned, the wireless power transfer, just so the audience understands. You're talking about wireless lane charging of electric vehicles? Is that what you mean?
Moment, what we're actually doing here is just developing a static wireless charging. So the idea is just, again, same as when we have a mobile phone, put it on a charging pad and start charging through magnetic field or inductive charging. For the mobile phone, we're looking at and the frequency, of course, is different. But for the technique that we're actually working, the application for is electric vehicles, we are working in different applications, but a specific project that I'm working with Government of Australia is around for electric vehicles. The application would be for the electric cars. And this is, at the moment, we started working on the static charging, and of course, it is adaptable later on. We will look at how it will be deployed as a vehicle on road when they can actually charge while driving. Perhaps the project will be ready perhaps by next year, and we are able to show that how it could actually charge electric cars in different range, perhaps medium voltage or low voltage at the moment.
Okay, that's very interesting. I have seen a few pilot projects around the world, but do you feel that this is something in the near term, this may become a reality, or is this like very far off, like a few decades away?
I don't think so. When I look at overseas, perhaps in Germany, even the US or in Netherlands or Israel, I can see a lot of pilot projects or trials, and even static charging has been implemented, and maybe in over a decade, we're moving towards having dynamic wireless power transfer or charging while driving in overseas. In Australia, the things are different. And to be honest, if you look at EV adoption, we are still at early stages. Of course, we've had a lot of improvement in terms of electric vehicles, and electrification is one of the top, I would say, targets for government to support. The things that we have to think is just bringing convenience. It's not just about looking at more charging infrastructure, which is, of course, one of the problems that we've had before, but not right now because we have a lot of fast chargers. But the thing is, when we talk about wireless charging strategies, another technique for charging electric cars is just bringing convenience for people and try to improve that. Hesitant to buy electric cars and just feel confident when they want to travel if they have another option like wireless. So in Australia, what we're actually trying to develop would be based on Australian standards. We have an international standard for wireless power transfer, but to be honest, to make sure that this system is working here in Australia, we also need to look at transport standards because we're looking at, the ground assembly, how the pavement works, and how we have a better and more efficient system that works for Australian standard as well. So that's what we're actually focusing on here.
I can see that sort of evolving with this concept of driverless cars, right? I mean, that's become a reality for taxis in a few cities. So having a charging lane or static charging at certain points, traffic lights, would seem to make sense even for driverless vehicles. But for people who are actually driving the cars, I'm just trying to imagine this, they would have to park their car for a moment and how quickly. So I guess the question is how much charge can be received into the batteries with these static and dynamic charging lanes? Or
I guess we can compare the technology with type 2 chargers that are available when we have a cable install and then it just charges like charging through the cable. The scenario would be the same. So if you have a wireless power transfer, the fact is just, again, depends on how efficient the system is, so it can actually transfer. But how quickly it gets charged is just like, it takes time depends on how the size of the battery as well. If you are looking at, a small size or medium voltage, that size, we are able to charge the car, for example, for around few hours. But if we can't actually compare it with fast chargers, but I guess it's just a matter of how much power we can transfer. If it just go with high power, we are able to also look at how fast the cars can get charged. In terms of static charging, yes, as you said, cars need to stay and get charged. And then maybe it takes, I don't know how long, depends on the state of charge, of course, 4 hours perhaps, or even more. To get charged depends on how efficient the system is, the system that has been actually designed. But later on, we can improve, and perhaps if we are able to transfer at least the current, the level of the current, that would actually increase as well. Same as the chargers. If you have a cable which we can, it's just 30 amps, depends on what, if you're working with 20 amps or 30 amps, we are able to transfer more power.
Very interesting. I think the public would, quite fascinated with those new technologies, and it's quite fascinating to see how it actually works. And do you have any prediction or of what in the next decade or so do you see any major technological changes that have to happen on the grid to support these new things? For what I'm saying is, there's this talk about transforming the grid, not just modernizing the grid, like catching up and building more transmission line. Do you feel that alternating current and three-phase and the way we distribute power in the cities, that has to be fundamentally changed? Or is it just a matter of increasing its capacity? Do we still use AC, or do we go to some hybrid AC-DC system? Or do you see that we still use fundamentally the same system, but it's going to be expanded?
That's actually a good question. When I think about the grid, of course, I don't look at it as one layer of conventional grid where we have generation, transmission, distribution, because it has different layers. So we talk about smarter grid, or I would say future grid, which has a different level of integration. We have control system, or we have this communication backbone. We're just moving away from centralized to decentralized. So I guess how to controlling this modernized grid, as you mentioned, is very important first. I'm not quite sure even over a decade, we are able to transform in terms of changing the AC scenarios or DC scenarios or just combining together. Perhaps with the help of AI, we are able to make the control system even, real time or even change those scenarios. But in terms of using hybrid scenarios, so that was another research going on to see how we have to, again, as you said, move away from focusing on AC or focusing on DC because they have pros and cons. So if we combine them together, perhaps they can actually complement each other and they use them. What I can see right now is the focus is more about this grid modernization, of course, the transformation is part of it, a part of the journey, but where and when we can get to that point that we can actually transform the grid, in 20 years or so, it might happen. But right now, the changes that I think is now happening and it's just maybe in 2 years time, if I sit here, I don't really, it just give me a great surprise, like how AI can actually transform things in power industry. Maybe that's the way that we have to go to control system and how we bring in more smart management in terms of dynamic or being adaptive. Because if we are designing something right now for now, and we don't really think about future, that is so wrong. We have to get the flexibility of the grid and make sure that we consider how to control that flexibility. That's, I think, something would be really helpful. If you're designing something and make sure that there is room for adaptation, that would be perfect. Like, we have these electric cars, the manufacturers, if they look at the option for potential vehicle to grid in OEMs, for example, or the manufacturer, then oversee this for future. If we don't have this opportunity, when the research comes to the point that we have now, or the policy is there, everything is there, and if this is working, we still have to wait for the capability of the manufacturing of the car. So I think we have to go hand by hand and try to oversee, not looking at the current grid, but of course see how the system works.
Yeah, I totally agree. I think we have to be very careful not to not just solve solutions that are in the short term here, but won't box us in decades and even to the next century down the track, that we make a regret of a technology choice or something that we do now that is going to cause problems later on. So I think a lot of utilities are quite rightly not going to take big risks to do something fundamentally different and then realize down the track it's going to be a problem. So stability is one thing, like stability in the technology. So I think that's what you were conveying.
Otherwise, it just creates a lot of costs involved, and wasting time perhaps. Yeah.
Right. So switching gears about the workforce in our field, do you feel that the workforce in Australia is ready or ramping up for these many innovations that are happening to our power grid in terms of training talent and having new engineers come in and replace retiring engineers?
I guess in terms of the education process, Australia has been acting very good. I think we have this really surprised me, of course, when I see a lot of engineers or future engineers working in and trying to get to that point. The support that government or, industry have for educating people are really good, and it's just increasing because of the changes. Perhaps if you look at education centers like universities, definitely try to be updated with what is happening right now and try to definitely educate, next generation of engineers. Make sure that when they want to step into the workforce, I can't say they are ready to just, go hands on. But what I can see from what we do here is just moving away from traditional and fundamental aspects of the education units that I'm actually taking. We have actually changed them to project-based learning. So trying to give the fundamental and theoretical aspect of the courses to students. And then we have coming with the lectorials or lectures. We have laboratories related to the fundamental aspects to understand for students to understand that fundamental aspects, and then we define a project related to what they have learned in collaboration with industry. We're just working very closely with industry to define the project such that they understand what exactly the real world problems are and how they can use those tools that they have learned in the lab, perhaps, for completing the projects for their courses. I think because we are just now moving towards this project-based learning and everything is just moving to hands-on activities, when they just want to go ahead and, work in industry, they are more ready. They know what software exactly industry need to work or they will require later on, or what sort of practical aspects of the grid they can work on. They have perhaps experience in working with PV solar systems or even other renewables, wind, in the lab and through the projects. And even, when I look at the industry is just supporting even the engineers to go back, take courses, and that really is helpful in terms of how they can train and get ready.
That's excellent. I mean, project-based learning integrated into your curriculum and working with the utilities and energy industries to define those projects. I think that's fantastic, Sara. So what advice would you give to young engineers or those who are just about to graduate or those even coming into university system who are embarking on an electrical engineering career? Do you have any career advice for them in general?
Yeah, sure. I think one of the first thing that I always believe is when we have students, I always tell them that if you are going to look at your future, first, your interest is in high priority. Of course, you have to make sure you are working or getting the education towards something that you really have interest on it. But because if we are in real, power industry and electricity generation and systems, there are a lot of changes. So I guess the main thing for students is just be aware of what is happening, to be updated with the system. They don't really need to just limit themselves to what they learn at university. They have to, because right now it's just, we have internet, we have a lot of opportunities to know more. So they shouldn't actually just limit themselves to what they learn at university or the fundamentals. They have to go further and see how the combination of AI perhaps or the power industry work together and how they are able to do teamwork. Because what I see from the transition that is happening, we can't only consider expertise in one direction. From whatever I have done through different projects, I see the opportunity that how we can work together from different perspectives. For example, we have electrical engineers to just work on the designing the system or, the smart systems that we're talking about. But then again, we have to prepare the infrastructure. The industry is quite, large. They can just work on the preparing in the infrastructure. So we need civil expertise perhaps, or we have to bring in mechanical expertise or economical aspect or the economic benefits for the system that you're actually designing. So to be able to work with others with different expertise, that is something that I think future engineers need to look and see how they can adapt themselves with what comes and then how they can negotiate or design the system in a, I think, interdisciplinary system rather than just focusing in one direction.
Okay, that's very, very fantastic. I mean, where can people find out more about your projects and learn more about some of the topics you've talked about from your perspective?
Some of the projects are now available in my profile in Macquarie University website. The details of the projects and perhaps if something new comes up, we'll share it through LinkedIn. I have some projects, in optimizing routing for electric shuttles, which is very interesting, or for example, this wireless power transfer, or quite a few projects related to renewable waste microgrids, not only in the regional areas, but how we're moving away and then have agrivoltaics when we just combine these agriculture and solar energy together, satellite imagery, or even floating PV solar systems. The information is available in my profile in Macquarie University website, and I'm more than happy to take any, if anyone had any questions, just drop me an email and I would be happy to explain more and be in touch, of course.
Okay, we'll put your Macquarie University profile link and LinkedIn addresses in this video. I think I'll add those after that. So this is a question that just came to me. As a person who's worked in industry and academia for many, many years, how do you balance your professional life with your personal life, and because you're involved in so many projects, and I think this would be good advice for people who are starting a career. How do you keep a balance between your professional life and personal life?
Very good question, Paul. And it's just very difficult to answer that because it's so hard to balance when you're in academy and work in academia. It's just honestly for people who want to work in this area, I would say they should actually love their jobs. It's very hard, of course, but the thing is the balance, I agree that the balance has to be there because I have a family, I have 2 kids, and it's been very challenging over the years. I guess you remember when I was actually studying at Curtin University and I had 2 little boys, and how challenging could be even for, specifically for female engineers that really want to step in these areas. I guess the main thing that kept me working and progressing is just the fact that I really love my job. I moved from industry to academia and I stayed here because I know that I can do research on the area that I really love. And then I am able to be in contact with the students and how it is really fascinating to see how they can progress, how they learn, and then I can even learn from them as well. So this is just, mutual, I would say, a learning process for me. It's not just me teaching. It's just me learning through my projects, through, teaching here at university. This is a great idea for people who are passionate to just see how things are changing continuously and you have to be updated. I would say a family is always a first priority, and I try my best to perhaps I have time for them as well. But as you also have, it's just really hard to balance between the work and of course the family. The only thing that just help us is just to see what the outcome is. When you see the progress, when you see the achievements out of this, how your work has a real impact or positive impact in people around you.
Yeah, I think my wife and I were talking about this, that you're a real great role model for young women who want to go into the sciences and engineering, and that you've been very successful at it, and we're very grateful for these role models. I have a daughter, and it's not easy to find good role models, and for people who do want to go into sciences and have a family and balance all these things. So I'm very grateful for your efforts.
I think one main important thing is the support that I've had and received from my family and friends. It's been amazing through the whole way from, over these years that I came to Australia without my close family around. It was very difficult having kids and, working at the same time. But the thing is, the support I have received from my sister or my husband and even my kids, they understand. And my friends, my close friends here in Australia, I'm really grateful for the family. And even, I have situations where my parents came here to help me and support me during a very challenging time. And this is really great. Without their help, and even, my colleagues at the university, we have been working together since I was at Curtin, and that is really important for me, how I was supported. Otherwise, I couldn't be here.
Very good. What gives you the most optimism about the future in our field? Does anything inspire you that you feel optimistic about?
I'm really optimistic about how, we are in the fast track, of course, and we have a target. We say, okay, we are trying to go to 100% renewables, and the question is if we can do that or not. But I honestly, I feel like that the next generation would be, I would say, more intelligent and more willing to work in this area, and how they can be adaptive. And with this, speed that I can see, and the role of AI in the systems, I would definitely think that I don't really, perhaps, I would really want to be here and, see this progress, what is happening and how we can get there in 20 years. This is really amazing how things are changing right now so fast. And one day we are able to get there, I think. So hopefully I could be here to see the new achievements and what we can achieve over a decade or so. But yeah.
Yeah, I agree with you. I think I can't imagine a more exciting time to be a power engineer. There's so many opportunities and ideas, and they're really gaining momentum and traction, and it's an exciting time to be an engineer. And as I share your enthusiasm about that, do you have any final thoughts or anything on your mind that we haven't covered that you'd like to say? Any exciting projects that we haven't talked about?
I love them all, but yeah, it's just the fact that it's all about how we are moving very fast and try to be updated. Otherwise, it's not really looking good. We're just trying to have a better, I would say, or more sustainable environment. The power system needs to be more resilient, more affordable for people who are actually living right now or even in the future.
Right. I mean, here in America, I've looked at the statistics. We've been having a lot more weather disturbances and natural disasters, ice storms, wildfires, heat waves, and many other things. But in Australia, I haven't lived there for many, many years, so I've forgotten like the natural kind of disasters you can have there. What has affected the power grid there?
I guess in terms of blackouts, the major one was in 2016 when we had a blackout in South Australia, and it was, again, we have had, I think, 2 storms coming in, and it was really bad, and we had 9 wind farms at that moment, and how it actually turned out, it was due to maloperation. Of course, we had a lot of energy coming in, and of course the maloperation of protection systems, because there was a limit for maximum power, and then they couldn't actually cope with it, and that blackout happens. But when I look up, I moved from Perth to Sydney, and when I came, it was exactly the time that bushfire happened here in Australia. Really very big bushfires, and we could actually see over the years, because the climate is just changing, and of course the planet is just warming so much. It really affected here in Australia and Sydney. Bushfire first, and then we had a lot of heat waves coming in and a lot of issues that we've had. And then later we have had flooding. I remember I was at home, working from home that day, and I was in a meeting. It was raining very hardly, and I felt like my feet are in the water. Flood came, and it was a disaster. It was very dangerous, of course, because I had a lot of plugs on the ground. So I think it was really costly for, government to try and avoid these things. And regional areas that I actually been working with, they had a lot of issues. They didn't have power. We had power outages for perhaps a week or so in some areas. It was really difficult situations for everybody to go through in terms of the electricity, I would say, generation, and how they actually deal with these problems, power outages that we've had at that time. Internet disconnection, of course, because we didn't have power and so on. Yeah, we have, of course, extreme weathers, and now I can see government is just trying to fund a lot of projects to deal with this, have the great resiliency and how to just prevent these events, extreme weather, of course, here in Australia as well. I know perhaps Australia geographically is different from US. You might have storms coming in more often, but here in Sydney, yeah.
Right. I actually remember that you had Mr. Mark Lobby from NERC as a guest. I've spoken to him a few times on projects we have here. And as for those who are listening, he's one of the senior managers at the North American Reliability Corporation, NERC, which oversees the reliability standards in the whole of North America. And I was wondering what you had learned from him. Did he have any insights into the Australian system? Or
I guess we were really fortunate to have him here, and he spoke with us, and also he was just looking at how, again, our system works, because he also visited AIM, Australian Energy Market Operator, and he had a chat with them as well. He was explaining, of course, about the US and how these changes are happening also in Australia, and it's just good to know. And then we had a discussion around, okay, how it works here, and perhaps what we can do better in terms of looking at the power quality or, stability of the power grid. In terms of the system, perhaps Australian and US would be a bit different in terms of how they're actually going through the regulatory systems. But I guess the point is, nevertheless, we have to look at how we're moving towards this energy. And as he mentioned as well, with virtual power plants or energy storages, definitely on the right. It was, I think, a year ago or so. So I can't remember exactly what the discussions was about, but yeah, that's what.
Okay, yeah, I just noticed on your LinkedIn he was there. I thought, that's very interesting. So, but I think that's a very good point, Sara, that although our two countries have very different energy sources, mixture, but there's a lot of commonality in solving these problems, a lot of challenges that we have in common in terms of resiliency. And I'm very glad that you and I are trying to look for ways to work together and see if there's any joint research between our two countries. And so we'll look forward to more opportunities to collaborate, Sara. Yeah, so I think we've pretty much come to about an hour, and I'm very pleased with these interesting topics you brought up, Sara. And I want to thank Dr. Sara Deilami for joining us on this podcast, Gridlock. And I really wish you the best in your career and all the best wishes to your family. And I'm very grateful to have you. And hopefully we can have you again sometime in the future with some new results and discoveries.
Sure, definitely. Thank you very much. I'm really happy that I could actually be part of this podcast. Appreciate your help. I also wish you and your family all the best. Thank you.
Very good. Thank you, Sara. I'm Dr. Paul Moses, and until next time, keep asking questions, keep learning, and remember, behind every reliable power system are engineers solving real-world problems every day. Thank you.